All right, let's talk about Java strings. On the surface, they seem so simple, right? Just text. But trust me, underneath that simplicity, there's a whole world of memory puzzles, performance traps, and some seriously cool modern magic. We're going to pull back the curtain and see what's really going on.
So, here's the plan. We're going to start with a classic trap that gets everyone, even experienced devs. Then, we'll dive into the memory model to see why that trap exists. From there, we'll talk performance, check out some futuristic features, and then wrap it all up with a handy cheat sheet you can start using like today.
Okay, first up, the string comparison trap. This is one of those classic Java gotchas, the kind of thing everyone runs into sooner or later. But once you understand this, everything else about strings just clicks into place. So let's set the scene with this little piece of code. We've got 3 strings, S1, S2, and S3. And look, they all hold the exact same value, hello. But pay close attention to how S3 is made. See that new keyword? Yeah, that little guy is the key to this whole mystery. So here is the big question. If we use the double equals operator to compare these, what happens? What do you think S1 equals S2 is going to give us? And what about S1 equals S3? Take a second, make a prediction. Got it? And boom, the results are in. S1 equals S2 is true. Okay, that makes sense. But S1 equals S3 is false. Wait, what? How is that possible? They both literally say hello. Now, this isn't a bug. It's a core concept in Java. So what on earth is going on here?
To really get this, let's use this fantastic analogy I saw once on Stack Overflow. Meet Jorman. Jorman's a successful guy and he owns 2 separate houses. This simple story is going to make everything crystal clear.
You see, here's the absolute key. The double equals operator is like asking, are these 2 the exact same house? Do they have the same street address? It only cares about the memory location. The dot equals method, though, is totally different. It's like a detective who knocks on the door and asks, is Jorman inside? It checks the actual content. So in our puzzle, S1 and S2 were pointing to the exact same house address, but S3 was a brand new house built somewhere else, even though the same person, our hello string, was living inside. So we know what happens, but now we need to understand why. To get why those addresses are different, we have to take a little peek inside Java's memory. And this is where we find 2 very important places, the heap and the string pool. First up, the string pool. Think of this as a special, super optimized storage area. Whenever Java sees a string literal, just text in quotes, it checks the pool first. If that string, say hello, is already in there, Java doesn't create a new one. It just says, hey, I already have one of those, and points your new variable to the existing one. It's all about efficiency. And this is how it all maps back to our code. The string pool is where our literals S1 and S2 ended up. When S1 was created, hello was put in the pool. When S2 came along, Java just pointed it to that same object. Simple. The heap, on the other hand, is the general-purpose playground for all new objects. So when we used new string hello, we were basically shouting at Java, hey, ignore the pool. I don't care if you have one already. Build me a brand new object on the heap right now. So let's just trace that one more time. First, our method runs, and it gets a little workspace on the stack for its variables. Then, S1 is created, and its reference on the stack points to hello over in the string pool. Next up, S2 is created, and its reference points to that exact same hello in the pool. But then comes S3, which forces the creation of a totally new hello object on the heap. See? 2 completely separate objects in memory, but they happen to have the same value. And just a quick side note on all this memory stuff. Java has this amazing process called the garbage collector. You can think of it as an automatic cleanup crew. It periodically goes through the heap and gets rid of any objects that nobody is using anymore. The string pool, however, is a bit different. Things in there tend to stick around for a lot longer. Okay, memory puzzle solved. Now let's switch gears and talk about speed. Because strings in Java have this one crucial property. They're immutable, which means they can't be changed, and how you build them can have a massive impact on your app's performance. This right here is the classic performance trap. Every single time you use the plus sign to add to a string inside a loop, you're not actually changing the original string. Nope, you're creating a brand new string object in memory and then just throwing the old one away. Imagine doing that 1,000 times in a loop. That's 1,000 temporary objects you're creating just for the garbage collector to have to clean up later. It is super wasteful. So what's the right way to do it? Well, you use string builder or string buffer. This table breaks it down perfectly.
The big difference, the real game changer, is mutability. Both string builder and string buffer can be changed in place, so no new objects are created every time. They're built for speed. For almost everything you do, string builder is going to be your best friend. It's the fastest. String buffer is a little slower, but that's because it's thread safe, which you only really need in complex multi-threaded situations.
Now, here's a little pro tip for you. In modern Java, since version 9, the compiler has gotten way smarter. It can actually optimize simple string additions behind the scenes, often turning them into string builder code for you. But, and this is a big but, when you're in a loop, the best, clearest, and most reliable practice is still to use string builder yourself. Don't rely on compiler magic. Be explicit. Your code will be easier to read, and you'll know for sure it's performant.
All right, we've nailed down the fundamentals and the performance stuff. Now, for the really fun part. Let's look at the cool new superpowers that recent versions of Java have given us for working with strings. The future is here, and it's pretty awesome.
I want you to meet string templates. Now, this is still a preview feature, but it is a total game changer. It lets you embed variables and expressions right inside a string using this cool backslash and curly brace syntax. Then a processor, like the standard str one, intelligently puts it all together for you.
I mean, just look at the difference. The old way, with all the plus signs, is so clunky, and it gets really hard to read when you have a bunch of variables. The string template version, it's clean, it's elegant, and it's so much easier to understand. It just says, hey, take the value of the name variable and stick it right here. Beautiful.
And this is where templates really blow your mind. Trying to build a block of HTML or maybe some JSON or SQL used to be an absolute nightmare, right? A mess of plus signs and escaped quotes. With multi-line templates, it just looks exactly like the final text is supposed to. It's readable, it's clean, and you're so much less likely to make a mistake. This is a massive improvement.
Wow, we have covered a ton of ground, from deep in Java's memory all the way to its cutting-edge features. So let's bring it all home and boil it down into a simple, straightforward cheat sheet that you can use right away.
All right, here are the golden rules. First, if you want to know if two strings have the same content, always use .=z. Rule number 2, only use double equals if you genuinely need to know if two variables are pointing to the exact same object in memory. 3, always prefer using simple string literals over new string so you can take advantage of the awesome string pool. 4, for building strings, especially in a loop, string builder is your best friend for performance. And finally, start playing with string templates for code that is just so much cleaner and more readable.
So there you have it. Strings are so much more than just a sequence of characters, aren't they? They're this beautiful, intricate dance between memory, performance, and language design. So now that you know how it all really works, I've got a question for you. What's the first piece of code you're going to go back and refactor? That loop using the plus sign? That comparison using double equals? Go take a look. I bet you'll find something.